Okay, so we're on to day 9. Let's see what they've got for us. Disk fragmenter. Struggling with his computer. He's trying to make contiguous. Let's shift the font down a bit. He's trying to make more contiguous free space by compacting all the files. Programs are working up to help. He shows you the disk map, a lot of numbers. Layout of the files from free space. The digits alternate between indicating the length of the file and the length of the free space. Okay, so 1, 2, 3, 4, 1 block file, 2 blocks free space, 3 block file, 4, 5. Okay. Each file on disk also has an ID number based on the order of files as they appear before they are rearranged, starting with ID 0. So the disk map 1, 2, 3, 4, 5 has 3 files. Okay. Okay, so we have to effectively unrun lengthen code that to produce a disk map of individual blocks. And then an amphipod, or whatever that is, would like to move the file blocks one at a time from the end of the disk to the leftmost free space block. Okay, so we move the 2 goes into there, next 2 goes there, then the next 2 goes after the 1. Okay, makes sense. The final step of this file compacting process is to update the file system checksum. The checksum is the result of multiplying each of these blocks' position with the file ID number it contains. The leftmost block is in position 0. Oh, we better hope there's nothing important in there because it's not included in the checksum. If a block contains free space, skip it. Okay, we can do that. All right, so let's go and pick up our sample data here. Wander over to our editor. So we're going to do our normal n09.rb. So there's our line of data. So let's think. We have to read it in, and while we're reading it in, we may as well decompress it at the same time because we have each digit. So def read compress. Oh, I keep forgetting to turn that off. I'm sorry. Read compressed map, and we'll pass in a file, and it's all on one line, so we can just do I don't know, line equals file dot getus dot chomp. So we now have our characters, and so we have to read through that one character at a time. So we know how to do that. That's going to be line dot each char do ch, and then that corresponds to a count. So we're going to say something like count equals integer ch. Oh, so now we have to alternate between adding file blocks and adding free blocks. Okay, we can do that. So let's have a simple flag here. Next is file, and the first one is a file, so that equals true. At the end of this loop, whatever we do, we're going to toggle next is file. Okay. And then at the end, well, I guess we should be collecting something, shouldn't we? So we're going to have to create a result. Let's stick it into a list for now, and then we're going to return that result. So we've got our next character. If the next is a file, else end. Okay, so if next is file, we are going to have to, oh, you know what? We have to keep the file number as well, right? So file no equals 0. So if next is file, then we have count blocks of that file. So we can do something like result append We can create an array of n elements by doing, create an array of one element and then multiply it by our count. Here we go. And now we've got that file, so we have to increment our file now. Else, free blocks. How are we going to represent a free block? Well, they use dots. Let's use bullets because they're just slightly bigger. So I'll have a constant that represents that times count. And we'll define free equals option 8 on a Mac. I have no idea what it is on any other system. Okay, so then down here we're going to return the result, not return. So okay, so let's read that in and print it out. Map equals read. We're reading from data, and we'll just do a p map. Okay, save that away. Pop up a, oops, there we go. So we're going to run 09.rb. Oh, okay, so what we got here? We got 0, 0. Oh, okay, so those are, each individual array corresponds to one of our times around the loop. So we're going to have to flatten that out, yeah? So we'll do that. Oh, actually, no, we can actually do it slightly better than that. Here, we're just, rather than using append, we can say dot concat. And just because it gets complicated, we'll put a parens around it. And the same up here. Dot concat. Okay, save that away. Okay. So let's do a map.join, just so we can see what we're looking at. Okay, so does that look like their thing here? 0, 0, 3 dots, 1, 1, 1, 3 dots, 2, 3 dots, 3, 3, 3, dot, 4, 4, dot, yep, okay. So it looks like we've got the decode down. Now what we have to do is to compress it. So we have our map. So now we'll just do map equals compress map. And the compression is that we move blocks from the end to the next available free block from the beginning. So I guess we need 2 pointers, one to the beginning, one to the end. And we'll just loop around and move stuff. Let's have a look. Our destination, the place we're moving things, is at index 0. And the place we're getting things from is, what is it, map? Oh, I'm writing compress here, which is not quite what I meant to do. Let's try actually writing a function. Def compress map, there we go. Source equals map dot length minus 1. I guess we can just alter the map in place, or we can be, well-behaved humans and actually duplicate it as we're going to mutate it. Let's mutate it as a cheap operation. Map equals map dot dupe. And then we're going to have to iterate now to move our 2 pointers and then move elements whenever we come across a non-free block. So dest is the high one. No, dest is the low one. Okay, so while dest is less than source. Okay, so now we're going to have if the map at the destination doesn't equal free. Okay, so we're in this position here, for example, down the bottom, where our first one is 0, so we can't move anything there. So what we're going to do is we are going to just increase our dest pointer by 1. So if it doesn't equal free, dest plus equals 1. Else if map source does equal free, so we're at the end or somewhere here and we're looking at a free one, we don't have to move it. So if map source equals free, source minus equals 1. Otherwise, we have a free at the bottom and a non-free at the top. So what we're going to do is we are going to say map. Oh, actually, we could just swap them, can't we? So if we do map dest, map source equals map source map dest. Cool. Now at this point we know that map source is a free node because we just moved the free one up there, and we know that map dest is not free because we just assigned it to it. So we can actually do dest plus equals 1, source minus equals 1. Okay, and then at the end of this, we will return our map. All right, so let's see what happens. Okay, so we've done something. Okay, 0, 0, 9, 9, 8, lots of ones, 8, 8, 8, 2, 7, 7, 3, 3, 3, 6, 4, 4, 5, 5, 5, 5, 6, 6. Cool. All right, it looks like we've actually successfully compressed it. So hang on, we have to do the checksum. Calculate the checksum, add up the result of multiplying each of these blocks' position with the file ID number it contains. Okay, well, that's easy enough. So we're going to do, let's actually stick into a method, why not? CS equals checksum map and put S CS def checksum map. So all it is it's the index times the value, right? So that's just going to be map dot reduce. No, sorry, map dot each with index. So we need the value and the index. Dot reduce 0. Okay, so we have the sum, and then we have the value, and I, and all that has to be is sum plus value times I. Cool. Is that really all we need? Let's have a look. Oh, what's wrong with that? String can't be coerced into an integer. That means that, yeah, look at, no. Oh, we're not allowed to add free ones in, are we? So let's do something about that. If value equals free, then the sum is unchanged, right? Otherwise, it's that. Oh, and we get 1928, and back over there, 1928. Excellent. Let's go get our puzzle input. Haha, okay. That's a nice long string. We'll copy that. We will paste that in as the first line here. Remember, our reader only reads the first line. So there we go. Save that away. Run it, and we get a nice big number there. Going back over to our browser, we will enter the puzzle input and submit. Hey, look at that. Well, that went remarkably well. I mean, normally I get about 100 typos and stuff. Well, I think there's only one in that one, so that was pretty good. Okay, let's have a look at part 2. First thing, the disk must unlock contiguous free space. Second, the computer is running much more slowly. because we split the files across multiple regions of the disk. This time, attempt to move whole files to the leftmost span of free space that could fit the file. Attempt to move each file exactly once in the order of decreasing file ID number, starting with the file with the highest file ID number. If there is no span of free space to the left of a file, any file, I guess, that is large enough to fit it, then the file does not move. So we're here. So 99 is a complete file, yeah? So we're going to take that, we move it down to the first free here, and it's gone from there. So we have 4/8. Oh, and it doesn't match. There's no space that has 4, so we have to leave the 8s behind. We're looking for 3 7s, so a gap of 3, and a gap of 3 is there, so we get a 7 there. We don't do the 8s again, so now we're looking at 6s. There's nothing with a gap of 6, nothing with a gap of 5. But the 4 4 here can move to there. Okay, so what are we going to do? So I've got to say my instinct here, it tells me that we should start from scratch. And the reason is that this time we're not dealing with individual blocks, but we're dealing with a chunk of blocks that represent a file. And so we want to be able to manipulate those whole chunks at a time. Now when we read from the compressed thing, we always read number of blocks in a file, number of blocks free. So they always come in pairs, except possibly the last one, we don't know about that one. But they always come in pairs, and so is that the unit in which to manipulate them? Yeah, probably, because then the index is the initial file number. Let's see what happens when we do that. Okay, so we're going to create a new program now. So back over in our editor, I'm going to edit 09b.rb. Cool. And we'll start off with our simple data again. So let's go capture that there. Def read compress. Oh, stop it, Copilot. Read compressed map file line equals file dot chomp. So let's think. What we need to do is to, all right, we can actually do this in one relatively long statement, I think. What we're going to do is kind of pretend I'm using Elixir here so I can chain things together, or it's not quite true. So this is going to be my list of characters. Now I'm going to say each char, right? I want to create the iterator of characters. And then I'm going to map them all to integers. Ampersand : 2i. And then I want to split it into 2, which means I can use this wonderful Ruby function or method, each slice. So that's going to divide it into chunks of 2. And now I've got my chunks of 2. I want to merge those into a big long list, but I need to store the number of file blocks, the number of free blocks, and probably also the file number. So I need 3 things. Let's create a structure. So block pair is a structure. It's called, the only reason for this string is it means that Ruby can give it a reasonable class name, which is kind of useful. And then we have the number of free blocks. Let's do it in the right order. The number of file blocks, followed by the number of free blocks, followed by the file number. Okay, so now what we need to do here is we're going to use reduce. Of course we're going to use reduce. So we're going to reduce over our list of slices. So let's just write this out for a bit. So what we're going to have is, a list that looks something like this. etc., etc. And what we want to do is to return instead a list of those structures where we have 1, 1, and then the file number is 0, and then 1, 2, 1, etc. So we need to collect those slices into, each one goes into a structure, but we also need to add the file number. And the file number has to increase each time around this loop. And that means the file number is part of the state. So what we're going to do is we're going to pass into our reduce function here a state of two things. It's going to be the target list that we're going to be building, and it's also going to be the file number, like that. The parameters to the block that reduce generates is going to be the result and the file number. So that's the accumulator that we're passing around the loop. And then the second parameter is going to be those tuples, which are actually the file blocks and the free blocks. Wow. And what we're going to do is we are going to append to our result one of our block player things. So block pair.new, and it takes file blocks, free blocks, and the file number. Okay. And then our next value of the accumulator is going to be that result, and we're going to increment the file number. That's almost like functional programming. Okay, let's see what happens if we run this. P read compressed map data. Good Lord. Oh, that's the previous one. I didn't run OB, that's why. Okay. Well, it's returned some structures to us. Look at that. So the first one is struct file blocks 2, 2, 3, file number is 0. Then 3, 3, file number is 1. 3, 3, sorry, 1, 3, 3, 1, 3, 1. Yeah, okay. So it looks like we're reading that compressed map in. Okay. Just so we can dump it out and double check, why don't we write, just for now, uncompress. So that's going to take our list of block pairs, and of course it's going to be reduce, an empty list, do. So we're going to add onto the end of our list the n blocks of file number, block.file, no times block dot file blocks, and that should be a list. So let's put our file blocks on, and then we have to do concat free times block dot free blocks. Boom, what does that look like? Well, let's find out. So let's say compressed equals, and then we'll do a P on uncompress. Compressed. Oh yeah. Undefined method file no for instance of array. block.file node. Okay, so let's see what's going on here. Let's just do a quick p block. Oh, that's a full list, that's why. Why is that happening? Compressed should be that list, right? So if I reduce over it, then block should be the first entry. So is map not that list? Hang on, let's output compressed here. Oh, compressed is a list. Oh. Yes. Okay, our reduce up here, the value of our reduce is the result and also the last file number. So if you look at what we're returning here, we're returning a list containing a list of the blocks and number 10 there, which is the file number. So we just want to return the first element of that. So if I just say dot first here, then hopefully, oh, I haven't defined free, have I? No implicit conversion from nil to integer. So look at this, we got all the way through our blocks. Oh, we get to the last one, look at this. File blocks is 2, free blocks is, oh, okay. So remember I thought this might happen, right? Back over here, if we look at our original input here, the last one there, that's the file blocks. There is no free blocks after it. So it should be, or implicitly it's 0. So I think what we have to do here is to say either free blocks or 0. And that way, if we're missing the free blocks at the end, we'll just tack on a 0. Oh, I did that in the wrong place, didn't I? It should be here when I'm creating it. Cool. Okay, so now what we've done is expanded it back out again. So let's just join that so we can actually have a look at it. Okay, so that looks like our original string. So I'm prepared to believe that we are correctly generating our list of blocks and that we can interpret that list of blocks as individual blocks if we need to. All right. So now we have to implement our actual moving the blocks down, compressing them in. So let's think about that a little bit. So let's say we have a list that looks like, okay, we have file number 1, takes 2 blocks, and it's got 3 blocks free. And then we've got a bunch of other blocks, and then at the very end here, we're going to have, say, file number 9, and it has 2 blocks. And it's the end of the list, no blocks free. So now we want to compress that. Let's make a bit more space because I think we're going to need it. So clearly what we want to do is to move this guy, which is 2 blocks long, and take 2 of those 3 blocks there. So I think what we're going to have to do is to take this one, take away all its free blocks, then insert our 9. It still takes 2, but now there are 3 minus 2, so there's 1 block free at that position. And now at the end here, we're going to have, I don't know, some random file number. I don't know what that's going to be. It takes 0 for the file, and we have 2 now free there. So if that's the case, then what we should have is if we add up the frees, they should be the same, right? In fact, we add up all the numbers. So 2 plus 3 is 5, 7, 2, 4, 5, 7. Okay, so we've actually kept the same number of blocks, and we have moved the 9 down to there. So I think that's what our algorithm has to do. Let's just put that in comments just so I can keep my brain going here. Def, let's call it move down. Why not? And we're going to take the map and we're going to take, I don't know, what are we going to take? Oh, I guess we have to start at the right-hand end, which means the highest file number. So let us take a file number parameter. So initially it'll be, say, 9, and then we'll move it down. Okay, to move down a file number, we first of all have to find that block in our map. And we're going to mutate our map, so we should probably do that. I don't know if that's necessary, but it seems to be tied to do that. Okay, so now we're going to find the source block. That's the block that we're moving. So the source index is going to be map.rIndex. That means index from the right. And it takes a block, doesn't it? Right. So we get passed in a block, and we're looking for the block whose file number is our file number. With a closing thingy. If we can't find it, then we've got ourselves a fatal error. So I think we should probably just say fail. Can't find hash. Back in my mind, I think I need to put parentheses around that call. Okay. So then we'll actually go and find that source block. Source index. This is the one at the end here, right? That's this 920 or whatever it is. So the number of blocks that we need equals source.fileblocks. Okay, so at this point we're looking in our map for a chunk, the first chunk that has that many free blocks. So I guess just to be on the safe side, no, let's do it the nice way. If needed is greater than 0, and so what we're going to do now is search forward in the map for the first block that has that many free. So it's going to be dest index equals map.index block.free is greater than or equal to needed. Okay, if we find that, okay, so what I'm thinking here is we don't want to search past the point we've just moved down, because that will move a block further away from the origin. So we want to say if dest index, so therefore it's not nil, and dest index is less than source index. So that way we only go up to, in this case, we'd only go up to here, and we wouldn't go and look for any free blocks past that point, which I don't think matters in this case. But if we're high, we're a long way down the list, and we don't want to be using, say we're here and we're looking for 1, we don't want to go past and use that one, because that would actually move that block up that way. So less than source index. Okay, so now we actually have to swap or insert. We have 3 things we have to do. We have to effectively zero this guy out. We have to zero out the free in this guy, and we have to insert a new block after that guy. And the trick here is going to make sure we do that in the right order so we can keep all the values that we need. I guess let's start with this guy. Okay, so let's call that the new end or something like that. New end equals, and it's a block pair. I don't know what we should put for the file number here. Let's put -1 just because it kind of like it's a flag. Oh, actually, no, what we could do is to say minus source dot file number. So it'll actually record in it the number of the file that we moved, which would be, I don't know if it'd be useful debugging or whatever. File blocks, well, in this case, we no longer have a file, so it'll be 0. And the free blocks will be the sum of the original free blocks and the original file blocks. So it's source dot file blocks plus source dot free blocks. So now we've created our replacement for this end, and so we can say map source index equals new end. Okay. Now we're going to create a brand new block for our new file. New file equals, and we could probably reuse source at this point, but I'm always a bit leery about doing that because you're never too sure who's got references to it. So if in doubt, create something new. That's also to do with kind of this idea of if you keep things immutable, life becomes a bit simpler. And I know I'm breaking that rule with map, but no, I'm not actually, because I'm duplicating it. Okay. So now we're going to create a new thing. The file number is going to be, am I insane here? Is it file number or file no? File no, okay. Is going to be the sources file number, yeah, because that's this guy we're moving down to here. So that guy becomes that. So file no is source.file no. File blocks is source dot file blocks, and then the free for this is going to be the original free minus the number of blocks we've used for that file. So free blocks is map dest index dot free blocks minus source dot file blocks, and we're going to store that into our map, and that's going to be an insert operation. We're going to insert it after the destination, so that's dest index +1, new file, and then finally we have to update our old one, and it hasn't moved, so I think all we have to see is map dest index dot free blocks equals 0. Ouch. Okay, that's a pretty gnarly bit of code. Let's look to go back and simplify that a bit later on if we want to. Just for now, let's do a little bit just to make it a bit easier to read. Okay, so now we have to drive this bad boy. It takes a map and a file number. So I think what I want to do is to say compressed equals, oh, we're not returning the new map. We have to return the new map. I'll do that in a second. Move down compressed file number 9, and then we'll output it again and see if we've actually moved it down. So back up here, we have to return our map, because remember at the top here we duplicated that map there because we don't want to change the original just because. All right, how many errors do you think we've got here? I'm guessing 4. Oh wow, okay. Dot free blocks, and I've got a X. Guess which character is next to my escape key? Save that away. Source index, I guess that would help if I had an equal sign there. So that's 2 so far, or maybe 4. File no is file no. 3. Oh, only 3 this time. Okay, so here we go. And look at that. It's actually moved the 9 down to there. Let's get rid of that bit of tracing there. We don't need that anymore. Don't even know where it is. Hang on. Oh, here. Okay. So yeah, so we've moved 9 down to there. So just because, let's just do this. No, let's just go for it. Okay, so we're going to write a quick loop here, right? We're going to go from 9 down to 1. So it's going to be the length of our list, compressed dot last dot file no dot down to 1, because we don't want to move the very base one. There's nowhere for it to go. And we're going to reduce our original compressed, and that's going to get passed in the compressed map and the file no. And I think all we have to do in here is to say uncompress, no, sorry, move down, map, file no. Okay, so it's going to return the result. And we just do a quick p uncompress result dot join. Well, you know what? Just to be able to see what's going on, let's just have next step equals move down p uncompress next step dot join, and then return next step. And that will let us actually see it each step along the way. We really don't need that anymore. Okay, let's see what this is going to look like. Oh, one of those things you make a mental note to fix and then you forget. Oh, look at that. So if we go back and compare that to the output that we're expecting, 111, then we move the 99 down. At the next step, we're going to move the 77 down, or 777 down, so it's 772. And then we can't move the 6, can't move the 5, got to move the 4. And then at the very end, look at that. That 2 that was there, we're now going to move down to here. So we start off with 00992111777, and then nothing's changed after that. So surprisingly, I think we actually got it. All right. So let us just comment those 2 lines out, because we don't be needing them. And then we'll go and pick up our puzzle, our full puzzle again. Remember, we only read the first line, so if I just paste that in there. Just make sure I haven't left any sponges in the patient here. Oh yeah, we don't need that. Oh, we don't need that. We need the checksum, don't we? And our checksum function is what? Oh, we got rid of the checksum function. Okay, let's go over here and copy it out of here. There we go. Yank. That's our checksum function. And what we want to do is to put us checksum uncompressed result. Okay, Just as a matter of interest, how long is that line? 19,999 characters. So that's 20,000 if you add the free block, so that's 10,000 files we're going to move. And we're probably n squared, so that's going to be a relatively expensive operation. Let's just see how bad it is. So back down here, we'll run our code. 4 seconds or so. So it's saying that's our number. Wander back over to the advent of code. Yay, another gold star. This is like being in primary school. Okay, so looking back at our code over here, speeding it up. So why are we taking like 3 or 4 seconds? Well, like I say, it's going to be, what is it, O(n) squared, and we're feeding it 10,000 things. So that's a relatively expensive loop. If I had to guess, what's taking the time here is the fact that we're doing a linear search from the end to find the block for a particular file, and then we're doing a linear search in the front to find the first insertion point. So this guy we could speed up if we were to map a file number to a block number, and we'd have to be careful that when we moved the file we updated that map, and that would get rid of that pretty much altogether, so that would make that linear. This guy we could speed up by having probably some kind of tree sorted by block size, free block size, so we could quickly log n down to find a free block, and then again we'd have to update that tree. Problem there is that our tree update is also going to be, still going to be log n or n log n. So it'll be quicker than this, but it's still not going to be a lot. My guess is that by just replacing this, we can increase the speed by a factor of maybe 2. This would also help, but it wouldn't be as big a change because there's always going to be a bit of fudging around in there. But yeah, I think that's done. And I think we were right to switch from our representation here, where it was just basically a string of characters, to here where we had a list of blocks. It made it more complex, but it means that this code here is dealing with things purely at a block level and not at a character level, because the character level would mean select the next characters that are the same and then splice them out and splice. That would be a real mess. This function is way too long, way too complex. So, I mean, we could probably take this part of it and move it into a separate function. I don't know if you could simplify this too much because you kind of need all the information all the time. So I think that's probably pretty much the way it would be. Anyway, 9 down, on to 10. Catch you then.